So now we want to go ahead and pick a winner. Wow, this is going to be so easy. Our code's almost done, right? This is actually where it's about to get interesting. So our pick winner function, we actually want it to do a couple things. Number one, get a random number, use the random number to pick a player. And we want this to be automatically called. I don't want to have to come back to this lottery and hit pick winner all the time. I want this to automatically happen. So let's just focus on these first two right now. Get a random number and then use the random number to pick a player. And we'll update this to be automatically called later. And we could even make this a public function where or a better external function where anybody can call this pick winner function to pick the random winner. But since it's external, we probably only want them to pick a winner once our lottery is ready to have its winner be picked, right? So what we could do is we can make sure that enough time has passed to actually pick a winner. So what we could do is we can create some variable called interval where we give our lottery an interval of time of how long it's going to last. I don't want to have to change this. I really just want to set it once and forget about it. So because of that, we're going to make it a immutable variable from the constructor. So in the constructor, we'll do a uint256 interval. And in here, we'll do I_interval equals interval. And we'll even copy paste this line. And we'll create a new state variable called IInterval. This is going to be an immutable variable, this interval. And this is where comments are helpful. We can say duration of the lottery in seconds. So we'll have in the constructor, we'll have some interval be passed, which will be the duration of the lottery in seconds. And then what we can do in pick winner, we can check to see if enough time has passed, by keeping track of the current block time and comparing it to the interval and the last time a winner was picked. So to get the current time, we can do block.timestamp, which is another one of these global variables, which is in seconds. We say the block.timestamp minus the last timestamp that we took should be greater than IInterval, right? This is to say, let's say the block timestamp is 1,000. The last snapshot we took was at 500. That would equal 500. And let's say the interval was 600 seconds. This means that not enough time has passed, right? But if the block timestamp was currently 1,200, which is if the block timestamp was currently 1,200 minus 500 is obviously 700. And if the interval was a 600 second lottery, that means enough time has passed. So that's why this line will work. But what we have to do is, though, we do have to take some snapshot of time. And this is going to persist. This is going to be some storage that persists so that we know this is probably going to be a state variable, a storage variable. So we do uint256 private s_last timestamp, like so. Our first timestamp will probably need to be set right in the constructor. Last timestamp equals block.timestamp. Right when we launch this, we'll basically start the clock, if you will. And now down here, we can check this. We could say if block.timestamp minus that snapshot, or better yet, let's do the reverse of this. Let's say if this is less than or equal to the interval, or actually let's just do strictly less than, we know this, we should revert, right? Because enough time has not passed. We want to revert. And this is where we would put one of our custom errors. However, we're going to refactor this code pretty soon. So let's just leave it like this for now.